In this video, we are going to talk about a new form of equations of lines, and it's called standard form. So standard form typically has three pieces to it. Obviously, there's an equal sign to make it an equation, but on one side, we have an x and a y variable, and those often have coefficients. Those would be numbers where the a and the b are. And on the other side of the equal sign is just a constant. We're going to call that c for right now, so just another number. So, how do we work with standard form? Well, let's take a look at our first example right here. 4x minus 2y equals 12. I know that's in standard form because we have the x term and the y term on the left side of the equal sign and a number on the right side of the equal sign. So I'm going to use the instructions here for how to graph that. So the first thing we want to do is determine the y-intercept. Now I can't just look at this like I was looking at slope-intercept form and know the y-intercept. I have to do some work. So these instructions give me the steps to do that. So I'm going to plug in 0 for x, and I'm going to solve for y. So here we go. I'm going to plug in the 0 for x, and now I have an equation to solve. So I have to do 4 times 0, that's 0, minus 2y equals 12. Well, 0 minus 2y, that's just negative 2y, equals 12. And now I'm going to divide both sides by negative 2. And we get y equals negative 6. So my y-intercept will be at negative 6. So this is my y-intercept. Great. So next step is to determine the x-intercept. So this time we're going to plug in 0 for y and solve for x. Okay, so 4x minus 2 times 0 equals 12. And now we're going to simplify that. So 2 times 0, well, that's 0. And 4x minus 0 is just 4x. So now I have to solve for the x by dividing each side by 4. So here I get x equals 3. So that means that my x-intercept is going to be, right, on the x-axis at a value of 3. So we can now finish this up with our third step, which is to plot the intercepts, right? Plot those 2 points and graph the line. So let's do that. So here is the y-axis, here is negative 6, and I can put a point right there. Here is the x-axis, here is 3, I'll put a point right there. And now I'm going to draw my line in. And there's my line. And I'll put some arrows at the end. And there it is. So when we're graphing standard form, we find both the x and the y-intercepts, and we're able to draw that line in. I wanted to show you a nice little trick that I do when I'm plugging in the zeros on this next example here. So notice that when we plug in 0, a term goes away. So like what I'm talking about is when we plugged in 0 for x, this whole thing goes away, right? And you're just left with this part of the equation. So if I'm going to plug in 0 for x this time, I know this whole thing is going to go away. I'm just going to write this part of the equation. So it's like a little shortcut. Sometimes I call it the cover-up method, because if I was in person, I'd show you with my hand that I'd cover this thing up. It's gone, because we plug in 0, it disappears. And we're just left with this nice little equation to solve. So I'm just going to start my equations there from now on. All right, so to solve for y, we divide by negative 3, and I get 5. So my y-intercept on this one is at 5. And now I'm going to do that same cover-up method again. So this whole thing, right, this whole thing here is going to go away, because if we plug in 0, we get 0 there. So now my equation is just 5x equals negative 15. And now we're going to solve this equation by dividing both sides by 5. And we get that x is negative 3. So the x-intercept here will be at -3. Now, something else that I would really like us to be able to do is to write these as points. Because what if that was the question, to just list the points that are the x-intercepts? So x-intercepts, right, we know the x value, we solved for it, and we know that the y value is 0. Whereas for the y value, sorry, the y-intercept here, we know the x value is 0, and we solved for the y. So that's how we would write those as points. So let's graph those. So our y-intercept's at 5, so on the y-axis at 5. X-intercept's -3, so here's the x-axis and -3. And now we can graph our line. And arrows on it, and we're done. So standard form really isn't that bad, as long as you're okay with solving these one-step equations here. All right, so we got one more example. We're going to do the same thing. We're going to cover up this x here, so that means we're left with -2y. Don't forget the negative is still with that 2 there. That equals 8. We will divide both sides by -2, and we get -4. So the y-intercept would be 0, -4. And now let's cover up the y term, right? This is all gone. So now I just have x equals 8. Awesome, no work there. So my x-intercept is at 8, 0. So let's get those on the graph. 8, 0, and 0, -4. Excellent. And our line. And we're done. Okay, so now there are a few weird things that we have yet to talk about, and we might have seen them before pop up in Delta Math, and that's vertical and horizontal lines. So let's talk about it now. The reason that these are weird, I should say that vertical lines are extra weird, is because their equations don't start with y equals. So notice that the x equals is what starts off this equation here. There is no y at all in this equation, and that's because y doesn't matter on a vertical line. Here's what I mean. Watch this. Whatever number this is, right? So if we're looking at this example here, we have x equals -3. That means that we're going to graph every single point that has an x value of -3. So I'll start it off with the easy one. There's the point -3, 0. But let's see, there's a point up here too, right? Isn't that point -3, 8? Right, this was -3, 0. There's a point right here, -3, -4. All of the points that have an x value of -3 would be right here along a vertical line. So the y value has nothing to do with this one. And that's how we get this vertical line. What's nice about these is that they're pretty easy to graph, right? You just have to recognize, oh yeah, x equals -3. All of the points where x is -3 would give me a vertical line. Now when it comes to a horizontal line, we still start with a y equals, right? But now there's no x in it. So the opposite thing is happening. The x value has no significance here. We're just going to graph all of the points that have this y value. So in this example, y equals 8. So we know that it's going to have a y-intercept up here, right? It's 0, 8. Look at how that looks. And all of the points that have y values of 8 would be along this horizontal line, right? Like, look at this. This is the point 8, 8. This is the point 5, 8, right? All of the y values are the same. We don't care about those x values. And that's where we get the horizontal line from. So we want to be able to recognize that. When we see an equation that's just x equals a number, we get a vertical line. When it's y equals a number, we get a horizontal line. But we also want to be able to know from points when that happens. So for instance, look what happens right here. What if someone gave me the points -3, 8 and -3, 0 and said, write the equation? Well, we know the equation, right? Because I'm going backwards here. But let's say this was a question. Probably you're going to find slope first. Look what happens when we find slope. We do 8 minus 0 over negative 3 minus negative 3. So on the top we get 8, but look what happens down here. Negative 3 plus 3 cancels out, and we get a 0 in the denominator. That is bad news. That is called undefined. This means no slope. That means I can't write a number for the slope. So I can't plug in to slope-intercept. I can't plug into point slope, right? The only thing I can do is say, oh, look, their x values are the same. And if their x values are the same, then this must be a vertical line, right? Because that's what no slope means. It's a vertical line. So that's why we would just write the equation as x equals whatever the x values were. With horizontal lines, let's see what happens with slope here. Look what happens if I do slope between 5, 8 and 8, 8. Okay, let's do 8 minus 8 on the top and 5 minus 8 on the bottom. We would get 0 over negative 3. Oh, that's fine. That's a 0 slope, right? So 0 slope gets us the horizontal line. So if I were to plug into an equation like slope-intercept form, there'd be a 0 next to the x. And look, I happen to know the y-intercept on this one, right? We put that in as the plus 8. 0 times x is just 0, and we wind up getting this equation. So horizontal lines aren't as confusing because you have a number for the slope. It's the vertical lines that screw things up. So hopefully that helps. And now you're able to graph any line that you are given.